Hi, buddy. This is Mr. Folly, and welcome to Podcast 3.3. We're going to talk about stoichiometry, which is converting from one thing to the other, and limiting reactants. We're going to do a little intro to reaction writing, and we're going to balance some equations. So let's get started. So chemical equations. Now there's some symbols for chemical equations you should be comfortable with. Solid is abbreviated a little s. Oh, come on. Yep. Gas is a little g. Precipitate is a little down arrow. And a liquid is a little L. Aqueous is a little AQ. And catalyst is something riding on the arrow. So if permanganate was a catalyst, it would be intense purple and it would be riding on the arrow. Okay, there's a difference between liquid and aqueous. Liquid means melted, or the regular state. Aqueous means dissolved in water. And reactions work very well dissolved in water because they're compact and they are still able to move and collide. Ions are always aqueous. So in AP chemistry, ions are always aqueous, meaning they're dissolved in water. Strong acids and bases are always written in ions. They are 100% ions, and they ionize 100%. Soluble salts in water are written as ions. Again, they're dissolved in water. Weak acids and bases are written as compounds. So, for example, HNO2 is a weak base, and it would be written together, but HNO3, nitric acid, would be written as H positive and NO3 negative. And gases are written as compounds. You would not ionize CO2, for example. You do need to know your strong acids. They are HCl, HBr, whoops, HI, hi, HNO3, H2SO4, and HClO4. And the strong bases are group 1 and 2 hydroxides. Okay, so for example, NaOH is strong because it's in the first group. FeOH taken twice is weak. Okay, so here we go. Write and balance the net equation for the reaction of calcium phosphate, I'll tell you that's solid, and phosphoric acid. Remember, phosphoric acid is going to be aqueous because acids are always aqueous. So calcium phosphate, Ca3PO4 taken twice. How did I do that? Oh yeah, calcium's plus 2, 2. Phosphates minus 3, 3. And I wrote it together, and I'm going to call it solid this time. Because it is. And phosphoric acid. Acids are always aqueous. Now, I write phosphoric acid together because it's a weak acid. It's not one of my strong ones. To form calcium dihydrogen phosphate. Okay? Calcium dihydrogen phosphate, and we'll say that is aqueous. It should have said, but that's what we'll do. Okay? Does that make sense? I hope. So notice if I were to balance this, remember I need the same number of things on each side. Now this is a weird equation that I picked, and I'm afraid it won't balance, but I'll give it a whirl. So I need 6 hydrogens, and I have 3 hydrogens here. So what I'll do is I'll put a 3 here, which will give me, well, let me show you the long way of doing this. If you're worried about something, you can write out the parts equally. So calcium, there's 3 calciums on the left. Phosphates, there's 2. H's, there's 3. Oh man, there's not 2 phosphates, there's 3 phosphates. I'm a sucker, aren't I? On the right hand side, calcium equals, now that I put this, well, let's do it before I put the 3 there, equals 1. Phosphate equals 1, and hydrogen equals 2. So I'll start with calcium and try and make that better. So I'll put a 3 here, which will change my calciums to 3, my hydrogens to 6, and my phosphates to 3. So now if I want 6 hydrogens, I'm going to have to put a 2 here, and I'm going to be bummed here because it's not going to balance. And I made up one that's probably is not going to balance. That's 6. That gives me 2 plus 2 is 4 phosphates. Darn it, I picked one. I wrote one that I should have written out and thought of before because this won't balance. But you get the idea. We'll balance one later. Whoops. What's the balance equation for combustible octane? I can do this one in my sleep. C8H18. If you combust something, you add oxygen to it. And if you combust something, you get the most common oxide of it. Most common oxide of carbon, carbon dioxide. Most common oxide of hydrogen, water. And that's it. Carbon equals 8. hydrogen equals 18, oxygen equals 2, carbon equals 1. Oh, by the way, I forgot to say this. No balance means no correct reaction. We'll go with that. So that means that I made up a reaction that just doesn't happen. Okay, so carbon is 1, hydrogen is 2, oxygen is 3. So to get 8 carbons, I'll throw an 8 here. And that changes my oxygens to 16 plus 1, 17. And it doesn't change my hydrogens at all. So if I want 18 hydrogens, I would have to put a 9 here, which would give me 18 hydrogens. It would give me 9 plus 16, 25 oxygens. And now I say, oh man, there's not a whole number I can put here to figure out what it would do. I sure wish I could put like 25 over 2. Well, if I do that, and it's not a bad thing, sometimes we let you do it with whole numbers, what I would do to get rid of this fraction is multiply everything by 2. So this becomes 2. 25 over 2 times 2 would be 25. 8 becomes 16. And 9 becomes 18. Isn't that nifty? And add them all up, and they will balance. I'm trying to hurry up because I've got stoich stuff that's longer. Calculations based on chemical formulas or equations are always go through mole. So number 126 in your book, if you don't write it down, it's here. Nitric acid made commercially by the Ostwald process, represented by the following equations. Blah, 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 blah. What mass of NH3 must be used to make 1 times 10 to the 6th kilograms of HNO3? So I'm trying to make 1e6 kilograms of HNO3. So I'm going to try and sneak this over here. 1e6 kilograms. Now, I hate kilograms. I'm going to change it right to grams. Okay? And since I know that there's a factor of 3 difference in there, it's 1e9. There are 1,000 grams in a kilogram. So 1e9 grams of HNO3 times dividing bar, grams of HNO3. Now, I want to convert HNO3 into NH3. So I've got to convert this into one of these two. This is the one to turn it into because I can then convert it backwards from here. Then I have this guy, and I got to convert it into one of these two. I'll convert it into this one so that I can use this guy right here. Then I got to convert this one into that one because I'm not an idiot. Okay? So, grams of HNO3 and moles of HNO3. Remember, mole counts molecules, basically. So figure out how 1 mole equals go to the periodic table. So hydrogen's 1.01, nitrogen's 14.01, and oxygen is 48 for 3 of them. So 63.02. 63.02 times dividing bar. Then I'm going to have moles of HNO3, and I need a relationship. I need an equivalency between nitric acid and nitrogen dioxide. So, moles of 2 moles of HNO3 equal 3 moles of NO2. See how the coefficients will tell me those equivalencies? Now comes the tricky part. I know I want to get out of NO2. And I know I want to go into NO. But do I use the 2 that's here, or do I use the 3 that's here? Now the relationship I'm looking at is NO2 to NO. So notice here, 2 NO2s will give me 2 NOs. And if you put 1 and 1, you're just smart at math, and that's great. And go ahead and do that, and that's fine. Now I'm going to use this moles of NO, moles, no, and convert it into moles of ammonia. So again, my relationship between these two is 4 to 4. I'm going to go 1 to 1, show you that I was good at math one time too. And if it says mass of NH3, then mass, that means grams. So I need to get out of moles of NH3 and go to grams of NH3. And 1 mole is go to the periodic table. 14.01 is nitrogen plus 3.03 for 3 hydrogens, and I get 17.04. I do all that math, and I get the answer, which will be one of your podcast questions, which is what is the answer to question number 126. So if you have this all set up, 1e9 divided by 63 times 3 divided by 2 times 2 divided by 2 times 1 divided by 1 times 17.04, and you'll get your answer. I should probably look to see what it is. Oh, wow. I'd have to actually look at what that answer is. Give me 3 sig figs. 134 in Zumdo. That's what I call serial stoichiometries. You have to do step after step after step after step. That's harder than typical, but you get the idea. Hello. The first two reactions have, look at this, blah, 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 have 87% and 98% yields respectively. The overall reaction yields 3 moles of acetaminophen product for every 4 moles of that reactant. What is the percent yield by mass for the overall process? Okay, so the overall reaction yields 3 moles of acetaminophen for every 4 moles of C6H5. So I started with 4 moles of this, and I have to convert it into 3 moles of acetaminophen, C8H9O2N. So I've got to convert it into this. So I'm going to convert C6H5O3N into chancl, right? Because chancl's here. Then I can convert chancl into chan. Then I can convert chan into acetaminophen. Okay, now if I've given you balanced parts of some of them, all of these equations are balanced already, which is kind of nice. Okay, so I know that you get 3 moles. So let's figure out how much you should get from here. So 4 moles of C6H5O3N times dividing bar. Moles, I'm going to get rid of C6H5O3N, and I'm going to convert it into moles of C6H8ONCl. The relationship here is 1 to 1. Ding, ding. It's like kissing your sister. Nothing's going on there. Then chancl is going to turn into chan, right? And notice it's a 1 to 1 ratio again, right? 1 to 1. 1 mole C6H7ON and 1 mole what am I looking at? 6H8ONCl. So now I'm in chan, and I want to go from chan into acetaminophen. So again, I've got a 1 to 1. Okay, so I'm just going to call this chan. I'm going to call this acetaminophen because that's what they call it. And notice I have 4, and this is going to be, it tells me my answer is the overall reaction yield 3 moles. What should I get? 4 times 1 times 1 times 1. I should get 4 moles of acetaminophen. Right? The first two reactions have 87% yield and 98% yield. So what that means, I'm going to have 4 moles, and then 87% of it, of means times, is going to go away. And then 98% of that is going to go away. And then X% of something equals 3. All right, and that'll give me the decimal form for it. So if I solve for X, X equals 3 over 4 and 0.87 and 0.98. 3 divided by 4 divided by 0.87 divided by 0.98, and I hope for a number less than 1, and I get 0.91. What is percent yield by mass for the overall process? Well, gosh, I didn't need to do it. 0.91, that's not a percent. 0.91, what I just found was step 3's. So that's the answer for B. Look at me overachieving. And then what is the percent yield by mass for the overall process? Well, if I should have got 4 and I got 3, that is 75%, but my pen won't write. So I'm going to go ahead and say there's a part 2 coming up. I hope you enjoy it. So there's a part 2 you're going to have to do. My pen is broken. Well, let's see if it'll change when I go to here. And will it come back to me? Oh, limiting reagents. Process. Well, let's see. Can I write? Hey, I can write. I don't have to go into part 2. That makes me happy. For a limiting reagent, we're going to convert moles of each reactant into product. Whichever reactant produces less product is the limiting reagent, which we abbreviate LR. The reactant that produces the most is the excess reagent. So let's do that. All right. So this is a real AP question. So iron 3 oxide can be reduced with carbon monoxide according to the following equation. Blah, blah, blah. 60.3 liters. Okay. So what we're going to do is just ignore this part for now. No, but that won't work, will it? So what we'll do is we will just say that I'll tell you what, I will give you the answer for that. So the number of moles is PV equals nRT. Why can't I go crazy? I think I just will. So it's 1.5. You don't need to know this at all. Shame on me for using an old one. 16.2 equals nR is 0.0821. That's a constant. And the temperature needs to be in Kelvin. Wow, 200 plus 273 is 473. don't need to know this. This is next chapter. So sorry. So 1.5 times 16.2 divided by 0.0821 divided by 473 is 0.625 moles. And I hit a button and 0.625 moles of CO. Okay, so how many moles are available? Didn't need to do that. Sorry, I wasted your time watching that. What is the limiting reaction for the reaction? Justify with calculation. So what I'm going to do is I'm going to take 15.39 grams of FeO and I'm going to convert it into iron. Then I'm going to take my CO and convert it into iron. Times dividing bar. Hey, 2 grams of FeO, and I'm going to go into moles of FeO. 1 mole is go to the periodic table. Iron is 55.85 plus 16 is 71.85. Then I'm going to convert my moles of FeO into moles of iron. And in this case, 2 moles of FeO equal 1 mole of that. And then that will give me an answer. 15.39 divided by 71.85 times 2 is 0.428 moles of Fe. Now I need to compare that with what 0.625 moles of Co will make. Co. So I'm going to get out of moles of Co by putting on the bottom and canceling and go into moles of Fe. Coefficient for Fe is 2. CO is 3. 0.625 divided by 3 times 2 is 0.417 moles of Fe. So how much is really made? The amount that's really made is this much. So the most this can make is this. The most this can make is this. Well, CO, I don't have enough CO to make this, so this is a sad loser. That means FeO is my excess reactant and CO is my limiting reactant. Okay. How many moles of Fe are formed? 0.417. Yay. Percent yield. Reactions typically do not get 100% yield because there are side reactions. There are transfer issues. There are incomplete reactions. So if A is supposed to meet with B and they're in a big beaker of water or whatever it is, and A is over here and B is over here, isn't it possible they just never collide? Oh, how sad. So Sam's true love could be on Earth, and he could be a goat herder in Afghanistan. Meh. Hey, that's bleeding. Didn't we talk about that before? Meh. But she will never find him because she's not going to climb the mountains of Afghanistan. Oh, that won't happen. So they may never hit each other. Okay? So one reason is they just never collide. The other one is a side reaction. Okay? Aaron's true love that's a new one. Aaron's true love might be wooed away by some other dude that she doesn't like anymore. So there you go. The other thing is transfer issues. If I'm trying to pour all of the water from here to here, doesn't it never work? There's always like a drop or two. So we lose some of that stuff. Oh, this would be the incomplete reactions. They never meet. Oh. Calculate percent yield by actual, measured yield, divided by theoretical, or calculated yield. So actual yield, which is measured, and theoretical yield, which is calculated, that's the stoichiometry part. Fraction of 11.9 grams of Chuckle 3 with excess chlorine produced 12 grams of CCl4. What's the percent yield? So 11.9 grams of Chuckle 3. Whoops, I put Ch3. Cool. And I want to figure out, I'm going to convert it into what the other thing they gave me. So when I do this, I can get another number. Isn't it weird I'm converting something I already know a number for? Well, let's see what happens. See if those numbers are the same. Hint, they're not. So going into grams, I always go through moles. So when I notice how I automatically go through moles for about everything. Carbon is 12.01. Hydrogen is 1.01. Chlorine is 35.45 times, times 3, and I parenthesized that. I've seized them. So now I'm in moles of this, but I want to get into CCl4. So moles of Chuckle 3, and I want to go into moles of CCl4. And notice the relationship here is 2 and 2. I'm going to go 1, 1. And then I got to figure out the grams of that. So 1 mole CCl4. And I'm going to go into grams of CCl4. Now, how did I know I did this? Okay, I have to go into moles of everything. So notice when I'm in grams of Chuckle 3, I've got to go into moles of Chuckle 3. When I'm in moles of Chuckle 3, I have to go into moles of CCl4. And then when I get into moles, I can finally go into what I want. So, grams of CCl4, 12.01 plus quantity, 35.45 times 4. Quantity, enter, 153.81. Now, this might be 12 grams, but I'll tell you right now it's not. 11.9 divided by 119.37 times 153.81 gives me 15.3. This is how much I should get. I didn't get that much. I got 12. Oh, why not? Well, some of my Chuckle 3 just didn't want to react with Cl2. They're more, I'm not really into chlorine. I'm just going to wait for like some bromine or some fluorine or something. But either way, it just doesn't happen. So my percent yield is going to be what I got, 12, divided by what I should have gotten, 15.3, times 100%. So 12 divided by answer is 78.3%. Review. Always go through moles, always go through moles, always go through moles, always go through moles. Cancel ions that don't form precipitate, weak acid, base, or gases. And that is it. Toodles.